Yes. Good morning, my viewer. Good afternoon. Good evening. Welcome to PNO, the Biologist, a platform where we explore the world of biology. I would request you kindly to subscribe to my YouTube channel for more educative biology videos. PNO, the indoctrinator. Today, we are going to look at the osmotic pressure. So, by the end of this particular interaction, by the end of this particular session, you are going to understand and appreciate at once the meaning or the definition of the term osmotic pressure. You are also going to appreciate and enjoy the various types of concentrations that may be found in your body, in your tissues, or even cells. Therefore, let us journey together. What is osmotic pressure? Osmotic pressure simply refers to the force that is developed by a hypertonic solution or a highly concentrated solution or a solution that has more of solute molecules than solvent molecules. But wait a little bit. What do we mean by the word pressure? Pressure simply refers to a force. What is force? Force is a push or a pull. For instance, if I have that pen there and I want it to move to this side, I will pull. So that is a force. So osmotic pressure is a force that is developed or created by a solution that has more of solutes. What are solutes? Jesus. A solute refers to a solid particle, a particle that is tangible. I want you to just think about the salt that you added to your food yesterday or yesternight or just this morning or afternoon or evening or whichever time or whatever time. It is a solid particle. So that's a solute. Like salt, like what? Sugar. So those ones are solutes. Then a solvent simply refers to a water molecule. Water molecule. Now, to understand osmotic pressure, it is wise to review the types of concentration. And we have the three types of concentration listed for you. Hypotonic solution, hypertonic solution, and isotonic solution. Let us demonstrate a hypotonic solution. When you have a beaker or a glass or any container of this size, and then you put water, not just water, distilled water, water that has been purified, water that is free of impurities, water that has been cleansed, water that has no sin, water that has no solid particle or solute. Pure water, like Mary, the mother of Jesus. Therefore, if I take this container and put water, and a tiny one here. I put salt, chumvi, or sugar, sukari, inside this bigger one. I want then stir. You stir. After stirring, then we give you the privilege to test, to drink, and tell us, did you test any salt or sugar in that particular solution? Because now it is becoming a solution. Obviously, without thinking, but through experience, you not hear any, not hearing, but you not test any. The taste buds in your tongue will not detect any sugar or salt in this particular solution in the beaker, because there is more water and less salts. So this type of a solution is said to be hypertonic solution. Let us demonstrate, my dear viewer, a hypertonic solution, a highly concentrated solution, a solution with more solutes and less solvent or water molecules. You have a beaker that is of this size, and then another beaker that is of this size. So this one is bigger than this other one. So this is small, and this is big, or this is large, and this one is small. Then in this other one, initially we had put water. You can see this one is initially, we have water that is there, not just water, but pure water. Then you take the salt or the sugar that is in the bigger container and add it to this our water through common sense that must be common. This particular concentration of sugar is high. When you add it here and then stir, and then you're given the privilege to test if it is sugar, the sweetness will be demonstrated by the facial expressions that you shall wear. So tasty, like you're enjoying Coca-Cola. Then, or yogurt, or any juice, the German juice, the sugarcane juice, sharubati. So when you put that and you start, there will be a lot of sugar that you will even be forced to add some water to dilute, to reduce the concentration of sugar. So such a type of solution is said to be hypertonic solution. Hyper, high, hypo, low. Then the third type of solution is isotonic solution. A solution that has an average concentration of salts and solutes. If you have the two containers or beakers, they are of the same size, and then we put equal volume or amount of water and what? Sugars or salts. Either you take this and pour on this other one, you take this one and pour in the other container A, you do the vice versa, and then you stir. If you drink, you'll be okay. It will be as if you're drinking Coca-Cola. The sugars and the water or the solvents are well balanced, are averagely concentrated. None is high and the other one is low. No. All of them are averagely concentrated. So that one demonstrates an isotonic solution. Now, let us go to our membranes. A membrane in your body. If you look at this membrane here, it could be the intestine of a goat, the intestine of a cow, the intestine of Corocuta, the black spotted African hyena. This membrane is semi-permeable. The membrane is selectively permeable. It is juicy. It allows substances that have smaller molecules or that are reduced in size to pass through. But those that are large in size to remain where they are. It's as if we can give an analogy to the gate to heaven. They say that the gate is so narrow. I don't want to conclude. Now, if you look at this other region A, you have a lot of salts or sugars. So this solution is hypertonic. The solution is hypertonic, highly concentrated. It has more sugars. But if you go on the part B or region B of the membrane, the solution has more water. You can see that you can even count the salts or sugars that are there. So you have more water this side. So this is hypotonic solution, lowly concentrated solution. Therefore, you should understand this. The solution that is this side is very thirsty. It is very thirsty. It is thirsting for water. It needs water because it has no water. The solution is dry. The solution has more water, salts and sugars. So it must develop a force. Remember what I did with the pen? It must develop a force that is going to grab, that is going to draw, that is going to pull water to itself so that it can bathe with water, so that it can feel nice, so that they are the same. So this type of solution, this type of force, that is being developed by a hypertonic solution is what we refer to as osmotic pressure. Sorry for that. Osmotic pressure. The force that is being developed by this highly concentrated solution to draw water to itself through a semi-permeable membrane. So we need to add that statement here, that it is the force developed by a concentrated solution or a hypertonic solution or a solution that has more of solute molecules than solvent molecules through a semi-permeable membrane. Yes, my dear viewer, we have come to the end of today's indoctrination. We have dispensed, or I have dispensed, knowledge on the osmotic pressure. We have defined osmotic pressure. We have also reviewed or recalled or remembered the three types of concentrations: the hypertonic solution, the hypotonic solution, the isotonic solution. And then we have also demonstrated how water is drawn by a hypertonic solution across a semi-permeable membrane from the other region where the concentration is very low, or a region that has more water. I would request kindly to subscribe for more videos in this particular channel. Until next time, let's meet again. Bye.